Do you have a compass at home? If you don't have, you can get one. It's a small rounded piece in which there is a magnetic needle, right. Now what you can do is you can take the tray of a matchbox and coil wires around it, and then of course make the circuit. Now when you keep the magnetic needle and pass the current, you will find that magnetic needle shows deflection. I will not give you the clue. Now I will give you the second situation. In second situation, when you have a magnetic needle and you bring a bar magnet close to it, it still deflects. Why? Because the magnetic needle points towards south and north pole, and when a bar magnet comes, then the effect is that you know this, that similar poles repel each other and opposite poles attract each other. So there is deflection. And when the electric current is passed through this wire, then also there is a deflection. So what does that mean? That means that these metallic wires, which are actually the magnetic material, when electric current passes through this magnetic material, it becomes a magnet, and that is why there is deflection in the compass. And such magnets which are formed by electric current are called electromagnets. One more activity to show how electromagnets act. You can take two nails which are about 6 to 10 centimeters and coil wire around them. And you can take about 75 centimeters long wire and now connect it with a cell and the switch, and then pass the electric current. After you have passed the electric current by switching on, and then you bring some small common pins close to the nail, and what do you find? The nails attract these small pins. The pins which were close to the nail, they got attracted and they were sticking to each other. Now, which substances attract magnetic material? The magnets. If the current is not there, if the switch is off, then if you bring these common pins, they are not attracted towards nails. But the moment you pass the electric current, they attract the pins, which means the nails have now become electromagnets. Now, these electromagnets have many uses. You know, strong electromagnets are used to separate useful magnetic material from industrial waste, because you see the industrial waste may have lot of scrap iron or other such things, and iron is quite expensive. We can't afford to just throw it away, but then it is in lot of waste material. How to separate the two? For this purpose, strong electromagnets are used. Even the eye specialist doctors use electromagnets, but they use small electromagnets to remove the magnetic material if it gets embedded in the eyes. So, like this we find that electromagnets have many uses. One most important use of electromagnet is in the electrical bells.